we have seen. Basically, from today we will start with the next point. That is what are the effects of vibration. So basically, you know what is vibration, how does the spin mass system actually work, what is kinetic energy, what is potential energy. Okay, what is the formula for potential energy, what is the kinetic energy. Okay, then what are the causes. Now, once we understand the causes, now what are the effects of vibration. Okay, why the study of mechanical vibration is very very important in case of the mechanical or any vibratory system. For that the answer is effects of vibration. There are a lot of effects of vibration, and that is why we have to study the mechanical vibration. The first is most prime movers. Now you know what is prime movers. Prime movers are nothing but the you can call it the IC engine, right? So IC engine is nothing but a prime mover, or you can call it steam engine. Okay, steam engine is nothing but a prime mover, or you can take an example of an electric motor. Okay, so these are all nothing but a prime movers. Prime movers means what? You can say the one which generates a power. Okay, you can say a mechanism, or you can say machine which generates a power, right? So they are nothing but the prime movers. So they generate a power, or you can say they are self-propelled. They are called as a self-propelled. Okay, and they generate a power and give to the system and run the system. Okay, so these are nothing but a prime movers. Okay, so most of the prime movers, for example, IC engine, pumps. You can take an example of a pumps, compressors. Okay, you can take an example of a electric motors. So all have a vibration problem. So basically, whenever see, you know that you have to design an IC engine because you know you need IC engine, you need electric motors, you need compressors, you need pumps, everything you need. So the Herculean task is to minimize the see. You first of all you try to understand that you cannot completely eliminate the vibration. No, vibration cannot be equal to the zero. So this cannot be equal to the zero. You can just minimize and control the vibration. So at what extent you can minimize and at what extent you can control, that is the you can say the role of a vibration or a design engineer. Okay, so vibration problems due to the unbalance in the engine. Unbalance engine. What do you know? What now? How does the unbalance create? Unbalance is nothing but due to the unbalanced mass. So as I said, that if m is the mass, okay, and its mass is at an eccentricity from the axis of rotation. This is see. I am telling you again and again. I am repeating this again and again. There is an axis of rotation about which this mass is rotating. Okay. There is a module number 6 where we will study the balancing of masses. The reason is same. So the rotating mass n is at a distance eccentricity from the axis of rotation, and because of this, the unbalanced mass NO is created, and because of this unbalanced mass, a centrifugal force is created. This centrifugal force always acts away from rotation, and I will see everything I will be taking you in the detail method analysis. Just I'm giving you introduction. So this centrifugal force is nothing but an unbalanced force, or the centrifugal force or this unbalanced mass creates an unbalance in the engines. Okay, and this why? Now you will say, sir, why this unbalance is created? So sometimes, depending upon the structure, depending upon the mechanism, the unbalance has to be created, and sometimes it is due to the faulty design or poor manufacture. So faulty design or poor manufacture is the main reason of the unbalance, and this, if there is an unbalance, it will create a vibrations, and these vibrations will cause excessive stresses basically in the rotating system. So now you know that there are a lot of IC engine is also a rotating system, pumps, compressors, electric motors. So many equipments are there where the masses are rotating about some axis, right? So even if you take an example of your automobile wheel, tire system, tire and wheel system, it is also rotating about the axle. So that is the axle is nothing but axle system. Okay, so there again, so there are a lot of rotating system. So balancing of a rotating system as well as balancing of a rotating system is very very important. So when you do the balancing, the vibrations will be automatically minimized. Okay, so unbalance. So so how will you reduce the unbalance? Go with a proper design, good manufacturing system, and there is a condition called the balancing. Okay, so we normally do the balancing of the masses. So you will be studying in the model number 6, rotating balancing and reciprocating balancing. Mathematically, how you do this? Okay. Next is causes rapid wear of machine parts, right? So if you know that if the vibrations occurs in the system, what will happen? It will cause a rapid wear of the machine parts like bearings and gears, for example. Now you know that these bearings and gears are connected on to the axle or connected to the shaft about which the masses are rotating. Okay. Now if you take an example of a axle, axle means what? Axle is nothing but the automotive live axle. So this automotive live axle will have a gearbox, will have a gearbox, it will have a differential, okay, it will have a bearings, right, it will have a braking system, it will have a wheels, okay, so everything is connected over here, right. So this axle which is connected to the gearbox, bearings, right, differential gears, then wheels, okay, so there, because of the vibration, the rapid wear of the machine parts such as bearings and gears, as well as the loosening of parts from the machine, means what? Loosening of parts means what? There are bolts, okay, there are nuts, okay, there are studs which are connected to the machine, so they will get loosened, right, okay, and your machine will start vibrating, okay. Now basically you might be imagining, sir, what will happen exactly if this is all happening, okay. So there is a condition called the resonance, which is the ultimate condition, so which is the infinity condition. So exactly what is the resonance and what happens at the resonance, you will come to know, okay. So, wheels of locomotive may leave the track due to the excessive vibration causing accident. Okay, so you know that the railways, or you can say the wagons, railway wagons are running on a track. Okay, locomotive. You know, locomotive means what? Railways. Okay, so if there are excessive vibrations in the railway locomotives, okay, wheels of a locomotives, they may leave the track, and it will cause a heavy accident or the heavy loss. Then resonance. Now this resonance is nothing but an ultimate condition. Exactly what is resonance now? I will explain in the next slide. Don't get confused. Basically, you try to understand that as a vibration engineer, as a design engineer, your first aim is to avoid the resonance. Because if the resonance occurs, the system will fail. The system will. The ultimate effect is the failure. The system will collapse. I have one. I have found out one video of a bridge where the resonance occurred and the bridge failed, right? So what is resonance? We will understand in deep. Okay. So basically, resonance leads to the large oscillation. Now, what is vibration? First of all, you know that vibrations are nothing but oscillations, right? So let us say oscillation can be simple harmonic motion, oscillation can be random, oscillation can be non-simple harmonic. So it's a cyclic motion, or it may be a non-cyclic motion, okay, depending upon the conditions, right. If earthquakes are there, winds are there, so they come under the random conditions. The machine vibrations may come under the simple harmonic motions also, okay. So these oscillations if increased to the infinity, right, if the oscillations increase to the infinity, I will show you one graph, small graph. Let us say that this is a graph of t versus, let us t versus amplitude, right? Now, what is amplitude? I will explain later on. Okay. So, if the oscillation goes on, let us say if the oscillations are very less initially, and if they go on increasing, and what will happen? They will go to the infinity. Means what? The oscillation went to the infinity. Okay. So, this will occur due to the resonance. Means what? A large oscillations. Okay. Basically, as an engineer, what you expect as an engineer, you expect that these oscillations should go on decreasing and they come to the zero. So oscillation should come to the zero as an engineer. Then and then we can say that you have controlled the vibration. But if the oscillation goes to the infinity, you cannot. You can say that the resonance has occurred. Okay. So these are nothing but the ultimate effects what we are going to see. So excessive deflections resulting in the mechanical failure of the system, right? Okay. So basically, now what is a resonance? It is a phenomenon which occurs whenever the natural frequency of the vibration of a machine or structure coincides with the frequency of external extension. Now let us take an example of a bridge, because I am going to show you the video of a bridge. Okay. Now let us say you are a civil engineer and a team of a civil, mechanical, all the engineers. Okay. So you design a bridge and you build a bridge. So while designing a bridge, you have decided a natural frequency. Now to decide a natural frequency is in your hand, because natural frequency is a design frequency. Okay, so omega is the natural frequency. Let us say that the external excitation force is nothing but a wind force. So let us say that this external excitation frequency is omega. So what is this omega? The frequency of external excitation. There is a, let us say, wind velocity, wind angular velocity radian per second. Now, as an engineer, you have to take care that this omega should not be equal to omega n. Means what? If the natural frequency omega n of a vibration of a machine or structure coincides with the frequency of external excitation, 100% resonance will occur, and your oscillations will go to the infinity and your system will fail. So maybe it can be a building, maybe it can be a huge bridge, maybe it can be a small structure, maybe it can be a heavy structure, whatever may be the structure. Any structure, any bridge, any machine will collapse if this happens. So you have to take care. Means what? You have to study the environmental factors also. Key, what may be the extreme wind velocity in that area. So accordingly, you have to design the natural frequency of a system. So you should know what parameters this natural frequency depends. Okay. So basically, what is resonance? Resonance is nothing but when omega is equal to omega n, that is natural frequency coincides the excitation frequency. This amplitudes go on increasing and they go to the infinity. And if the amplitude goes to the infinity, the system will fail. There will be a total collapse. Okay, right? So this is the next vibration of an instrumental
The
panel.
voice is breaking, sir.
It is breaking now, or it is breaking from a starting. Hello. Now okay. Now am I audible? Any other? Only he is
Yes,
feeling
sir.
that. बाकी सगळ्यांना माझा आवाज येतोय का फक्त त्यालाच येत नाहीये म्हणजे आपल्याला कळेल की त्याच्या इथे प्रॉब्लेम आहे की माझ्या इथे बाकी अजून कोणाला व्हॉइस ब्रेक येतोय
Yes, sir. Voice is breaking, sir.
व्हॉइस इज ब्रेकिंग
Yes, sir. For the last half minute.
ओके ओके वेट आता येतोय का व्यवस्थित आता येतोय Okay. तुमच्याकडचं पण थोडंसं नेटवर्क चेक करा मे बी तिकडे इश्यू आता आवाज येतोय का सगळ्यांना व्यवस्थित
येतोय सर.
ओके ओके तेच म्हणतो चलो so what I was talking, the vibration of the instrumental panels can cause their malfunction or difficulty in the reading the meters. So what I mean to say is that if let us say there is some instrument and if you want to take a reading of an instrument, any instrument, let us say you are measuring some frequency, okay, with the help of this instrument you are measuring some frequency or you are measuring some that you are measuring any you can say parameter, you are measuring let us say speed, okay, and if these instrument panels are connected to, let us say, any foundation, or you can say any machine where the vibrations are occurring, right? So what will happen? The vibrations will disturb this instrument panel, and it will cause their malfunction, and you will be a difficulty reading the meter. So wherever you are mounting the instrument panels, or wherever you are mounting the instruments, okay, you have to take care that you have to isolate the vibrations. You have to isolate the vibrations. Means what? Let us say this is an instrument. Okay, this is an instrument, and this is a, let us say any a foundation. Let us say this is a foundation. Okay. Now what will happen? The vibration may go from foundation to instrument, or vibration may go from instrument to foundation. Okay. So if this vibration from instruments are going to the foundation, or let us say instrument or a machine, then this foundation will break. And if the vibrations are occurring at the foundation, okay, so let us say that this vibration may disturb this instrument. So what do? You have to put a isolators. Okay, so this is a model number 6. So this isolator will isolate the vibrations from the instrument to the foundation or foundation to the instrument. Not necessarily it should be a foundation. It can be any. You can take an example of a road. Uh, let us let us take a small example. Okay, let us say that this is a car. Okay, this is a car and these are the roads. Okay, now tell me uh, how will the vibrations occur from the road, how will the vibrations occur from the road and will go to the car, and how will the vibrations occur in the car and will go to the road. Now what are the source of vibrations in the car? Anybody? What are the source of vibrations in the car? In the car मध्ये vibrations कुठून येणार आहेत किंवा तुमच्या बाईक मध्ये? What is the source of vibration? Anybody?
Engine.
Just time. Engine, yes. So source of vibration is nothing but a engine. Now tell me, how will what are the source of vibration on the road? What are the sources of vibration on the road? Yes. How will which force will be acting on the vehicle through the road? आता सध्या तुम्ही रत्नागिरीमध्ये गाडी चालवत असाल तर तुम्हाला जाणवत असेल. सध्या तुम्ही रत्नागिरीमध्ये गाडी चालवताय सगळेजण कुठल्याही एरियामध्ये तर तुम्हाला व्हायब्रेशन जाणवतात तुमच्या पाठीला. वाय? Anybody? I'm just giving a small example. का रत्नागिरीचे रस्ते बघितले सध्या कसे आहेत? काय प्रॉब्लेम आहे रत्नागिरीच्या रस्त्यांमध्ये? एनीबडी? हॅलो? येस. रोड म्हणजे रस्ते रत्नागिरीच्या रस्त्यांमध्ये सध्या खड्डे आहेत किंवा स्पीड ब्रेकर्स आहेत, राईट? सो रफ रोड, त्याला आपण म्हणतो रफ रोड. सो वेन एव्हर यू आर ड्रायव्हिंग अ व्हेकल ऑन द रफ रोड, सो द रोड कडनं पण फोर्सेस येणार आहेत आणि कार कडनं पण फोर्सेस येणार आहेत. ओके, सो बिकॉज ऑफ दिस फोर्सेस द व्हायब्रेशन्स विल क्रिएट. ओके, नाव what is the isolator in this case? So what we have done, we have designed an isolator. Now tell me, what is the isolator which is isolating the vibrations from the car to the road or maybe road to the car? First of all, tell me, what is the isolator which isolates the vibration coming from the road to the car? Fast, be fast. Any? What is that?
Suspensions.
Yes, your automotive suspension system. So they are isolating it. Okay. So this is what we will be studying in your module number 5. So similarly, in the case of this, the vibration of the instrumental panels, you have to isolate that. Transmission of vibrations to the human beings result in a discomfort and loss of efficiency. Now, you know that this vibration has also effect on the psychology, or you can say the human psychology, or you can call it as a human body, physical. Okay, so discomfort, loss of efficiency. Okay, because you see, if I say you that travel by a car or travel by a, you can say a vehicle which do not have a suspension system overnight. मी तुम्हाला सांगितलं एक रात्रभर तुम्ही जर्नी करा, do a journey of 24 hours which is not having a suspension system, proper design suspension system. Okay, what will happen? You will be feeling a continuous vibration from the road surfaces, from the vehicle wheels, right? And it will go to your body and you will feel a discomfort. So because you always want a good suspension vehicle. For example, a luxury buses and all, they have a good suspension vehicle. So you are able to travel overnight very easily. I hope you understand this. Okay. The vibrations and noise generated by the engine causes annoyance to the people and sometimes damage to the property. So due to the vibrations, noises are also generated. So that is also discomfortable. It is not comfortable to the human body, right? Now let me show you some video. So this is an example of a. So now I am going to show you example of a resonance. Okay. So exactly what resonance can do. So this resonance is nothing but a omega plus omega. So this is an example of a Tacoma narrow bridge during wind-induced vibration. So this wind velocity is nothing but omega. So what is the external exciting force? Omega, that is nothing but a wind-induced vibration. And omega in n is nothing but a natural frequency of this bridge. Okay. So the bridge opened on July 1, 1940 and collapsed on November 7, 1940. So July, August, September, October, November. So within 5 months, this wind, this 5 months, this bridge collapsed. Why? Because of the resonance. Now exactly, initially what happened? This bridge started waving, swaying. Swaying means what? Initially the vibrations was less. So if I draw a graph of this, let us say this is nothing but the time. Always you know that this graph is called the time response analysis because vibrations are related. So vibrations are related to the two things: time response and the frequency response. So module number 3 and 4 is time response, and module number 5 is a frequency response. So let us say amplitude. So initially, during the starting of the July, the amplitude was very less. Then amplitude started increasing, and it went to the infinity, and finally resonance occurred. So why resonance occurred? Because omega was equal to omega n, right? And this bridge collapsed. I will show you one video, and then you can see. Okay. Okay. So can you see the video, everyone? Exactly, I am just going to see what are the vibrations and what is the extreme condition of the vibration and what if resonance occurs. So I hope everybody is able to see the video. Please message me yes or no. Okay. So initially they are showing the construction of the bridge. Okay. Yes. Okay. So initially you can see it is a construction phase. Then grand opening July 1, 1940. So the bridge was opened. Okay, narrow bridge collapse 19 November 1, 1940. Now you so know that the wind start. So now the bridge was induced with a wind vibration. You know, na? Because of the so wind. Okay, gale causes bridge to sway. Now you can see how. Can you see here how that particular bridge is? You can say waving or swaying. Okay, so initially amplitude was very less, and that it went on increasing. Okay, so you can see here. So these are called as the vibrations. Can you see here? Are you able to see vibration? So these are nothing but the vibrations. So initially the vibrations are very, very less. But once the resonance occurs, amplitude goes on increasing. Okay. So this can happen in any machine. Try to understand that. Okay. And finally total collapse. So now tell me, have you understand this? Have you understand? So can you see? So from this video, it is clear that what is resonance and what vibration can do. Okay. So whenever they constructed the bridge, okay, they might have taken a care of a natural frequency omega n, but at some due point of time, the omega was equal to omega n. Okay, so that is why you have to take extreme care whenever you're basically whenever you're building a huge structure. Whenever you're building a huge structure, you have to take extreme care of this omega n because omega is in not our hand. Let us say wind velocity. Wind velocity is not in our hand; it is in the hand of the nature. Or it is in the hand of the God environment. Okay, it's completely a natural calamity. It's not in a hand. So considering where actually you're building the area, building the bridge, okay, you have to accordingly design in omega n, and you have to design omega n in such a way that this omega is equal to omega n will never happen. So now tell me, have you understand this? I will move on to the forward. Have you understand this? What is vibration? And okay. So I hope it is clear to you exactly what is resonance. Now you might have seen, you might have understand what are the effects, what are the causes, what is the vibration. Now basically, what are the uses of vibration? That is also you might be happy to hear that, or I am very happy to share that there are vibration also has some uses. It also has some good causes, good advantages, right? So means like you feel that vibrations are very comfortable in some cases, or you can say that the vibration makes you happy. Okay. So if I'm saying that vibration makes you happy, can you give me any example? Any example where vibration makes you happy or the uses of vibration and any other example? What are the uses? Because that is why you cannot completely eliminate a vibration because vibrations are also useful. Yes, anybody? Any good example or uses of vibration? Yes. Anybody? If I'm audible, am I audible to you? Are you able to hear me? Anybody please speak? Are you able to hear me?
Yes, sir.
Why? Yes, Rahul, why are you able to hear me? Well, my question is, why are you able to hear me?
So vibrations.
Vibration means what? Please elaborate. Please explain why you are saying that due to vibration I am able to. You are able to hear me. Yes, Rahul.
Sound
Sir,
travel.
what we speak travels through vibrations.
Okay. Okay. So vibrations of a tongue you are calling, right? So vibration of a tongue, right? Na?
Yes,
Okay. But why? How are you able to hear? I'm asking you. I
Sound wave.
am only sound wave. I am able to speak. I am able to speak. No, don't go into the air. Don't go into the environment. Just talk about your physical body. I am able to speak because of the movement of my tongue. It's a one sort of vibration. You are able to hear because of your ears ना. तुम्हाला कान आहेत म्हणून तुम्हाला ऐकायला येते ना. मग त्या कानाच्या आतमध्ये व्हायब्रेशन्स होतात ते तुम्हाला जाणवलं का कधी? Have you feel a vibrations in your ear? So there is one called as an ear drum. Ear drum म्हणतो आपण. Ear drum म्हणजे काय तुमच्या कानाचा पडदा. तो कानाचा पडदा तुमचा व्हायब्रेट होतो. Ear drums vibrate and that is why you are able to hear. Then do you like music? Anybody who don't like music असं कोण नसेल. सगळ्यांना म्युझिक आवडतं. म्युझिकल इन्स्ट्रुमेंट्स आवडतात सगळ्यांना. So I think musical instrument, guitars and all, they are based on how whenever you are playing a guitar, so the strings, whenever you are playing with the strings, so they are based on the vibrations only, na? Right? Then everybody like to take a massage, head massage or face massage. Everybody likes to take a head massage or face massage. So that machine of face massage or a head massage is also vibrating, na? Yes. So this is all about the vibration, okay? So most of the human activities involve vibration in one or the form. We hear because our eardrums vibrate, and we see because light waves undergo vibration. Now you are talking about the air layer vibration. So that is why they are nothing but the light waves undergo vibration. That is why we are able to see, right? Then the breathing, very very important. Breathing is also associated with the vibrations of lung, and walking involves the oscillatory motion of the legs and hands. Okay, so these are nothing but a good uses of vibration. Okay, we speak, as I said, we speak due to the motion of larynges, that is the tongues, right? Then useful for vibration testing equipments. Okay, vibration is useful for vibration testing equipments. Okay, so vibration testing equipment, vibratory conveyors, hoppers. Okay, sieves and compactors, washing machine, right? Electric toothbrushes, dentist drills, clocks, and electric massage units. So all are nothing but the use of vibration to give us a comfort feel, right? I hope you have understand now the uses. Improves the efficiency of certain machining, right? तर तुम्हाला certain machine ची efficiency वाढवायची असेल, like casting, forging, welding processes, this vibration is very very important. Okay, and employed to stimulate earthquakes for geological research. If you want to stimulate the earthquakes, you have to know the effects of earthquakes, when the earthquake will occur. Again, the vibratory instruments are also used. So there are a lot of uses of vibration. I hope guys you have understand this. Okay. Now basically, as I earlier said that you cannot completely eliminate. No, you cannot. You cannot completely eliminate the vibration. You cannot completely eliminate the vibrations. Okay. So if you are not able to completely eliminate the vibration, so what is the option with you guys? The option is only that you have to reduce the vibration. So now, how will you reduce the vibration? You should know certain condition. Na? You cannot be a directionless. If I said that go and travel to Mumbai, so you should know how to go to Mumbai. What is the route? The route is very, very important. The direction is very, very important. So you can be innovative. You can be innovative. You go by ship. You can go by plane. You can be innovative. You may go by walking also. You can be innovative, but at least you should know the direction. So removing the external excitation is possible. Now try to, for example, if you want to remove the vibrations, okay, now you know that resonance will occur when omega is equal to omega n, okay. So if possible, try to remove this external excitation. Now this is not possible at every time. Let us say if you are building a bridge, okay, so it is not possible to remove the wind velocity. It is not possible to completely eliminate the wind velocity or wind vibration. You can just reduce it. How will you reduce it? By selecting a proper area, okay, where the wind vibrations are very less. By using a geological research, right? So you can just eliminate them. But in some case, you can remove the external excitation if possible. If possible, this is the first thing. Use shock absorbers. Now in automobiles, we are using a dampers. Now in automobiles, we are using a dampers. Okay, dampers means what? It is called as a shock absorber. Spring is not a shock absorber. Try to understand that. Okay, spring and a damper. A damper is a different. Okay, damper and spring. Okay, these are the two different things. So shock absorbers, right? So in automobile, we are using a combination of spring and dampers, right? Then use dynamic vibration absorbers. Dynamic vibration absorbers in some cases, advanced cases. Okay, and last is place the system on proper vibration isolators. Use proper vibration isolators. Okay, so there are different vibration isolators which we will study in the model number 5. Okay, and putting the screen if noise is objectionable. Okay, so if the vibration noise is disturbing you, you can put the screen if the noise is objectionable. Okay, so these are some, you can say, reaction of vibration. Okay, now, so basically guys, now I have given you the complete overview of a vibration. What are the effects, what are the causes, I have shown you the video. Now I will start with my actual analytical part. Now just message me, have you all understand the basics of vibration, or you can say the introduction of vibration? Hello? Yes or no? Okay, great. Okay, now important and terminology in the vibration. The first is simple harmonic motion. Now, guys, I will not go into the deep because you have already studied it in the 11th standard, 12th standard physics, or maybe first or second year. Simple harmonic motion. What is simple harmonic motion? Everybody knows. Okay, just I am interested in the fundamental. So there is a fundamental equation of a simple harmonic motion which we have derived. Okay, so if you see into this picture, let us consider a point P. Can you see this point P? Okay, this point P is moving along the circle. This point P is moving along the circle, right? Now this point P is moving along the circle. Let us take an example of a point P which is moving along the circle with a velocity, angular velocity omega radian per second. Omega radian per second, right? This is what is happening. Okay. Now, now let's come to the next point. When this point P is moving along the circle with the angular velocity omega, okay. Now let us say that initially this point P was here. This point P was here at the initial position. From initial position, this point P went to P dash. Okay. Now let us say that x is the displacement of a point P from the mean position. What is the mean position? This is a mean position. Okay. So from mean position, this distance, let us say it is nothing but the x. So what is the small x we are doing? So this small x is nothing but the, you can call it as an initial displacement. This small x can be called as an initial displacement. Means what? This point P is at this mean position and now it went to this another position. So the distance between this point O and this point EP, this vertical distance is nothing but the x, that is a small x. Okay. Now guys, there is a big difference between the small x and capital X that we have to understand here. Okay. Now basically you understand that the small x is nothing but the displacement of a point P from this mean position to this distance. Okay. You can consider any distance, right? Now next let us say that x is the maximum. What is this x? This x is nothing but the maximum displacement. Okay, x is nothing but the maximum displacement. Now maximum displacement means what? What is the let us say that if x is the displacement, if x is the displacement of a point P from the mean position, what is the mean position? O. या मीन पोझिशन पासून तुमचा x हे डिस्प्लेसमेंट आहे, तर तुमचा हा मॅक्झिमम डिस्प्लेसमेंट कुठे असणार आहे? इथे असणार आहे ना, x ह्या पॉइंटला. म्हणजे p जेव्हा तुमचा ह्या पॉइंटला येईल. सो लेट अस से दॅट दिस मॅक्झिमम डिस्प्लेसमेंट इज नथिंग बट द कॅपिटल x. Okay, so I hope you understand. Now tell me, if x is the maximum displacement, Now, anybody knows what is this maximum displacement called as? This maximum displacement means what? What is the maximum displacement? तर आपण काय म्हणतो? Maximum displacement आपण काय म्हणतो? We called it as a amplitude, na? What is amplitude? Amplitude is nothing but a maximum displacement from the mean position. Okay? So बघा, आता जर मला amplitude represent करायचे असतील तर बघा, these amplitudes are nothing but it's a simple harmonic motion. You can see, na? So this is nothing but a maximum amplitude. Okay, so this is called as a, that is nothing but a x. So this x is the maximum displacement, which is equal to a, and what is a? A is nothing but an amplitude, right? So you can see that is why you are getting this a sine wave curve. A sine wave सारखा तुम्हाला curve मिळाला. Okay, म्हणजेच काय? These are nothing but the amplitudes. So this distance, try to understand that this distance is nothing but the x is equal to a, that is the amplitude. Okay, this x, small x, is nothing but a displacement. I hope it is clear to you. Okay, is it clear the difference between the what is amplitude, what is capital X, what is small x? Okay, and let us say that this point P is turning from this position or moving from this position O, that is mean position, to the point A, and it is swapping the angle theta. It is swapping the angle theta. So this angle is, let us say, theta, and this theta is always equal to omega t. T is nothing but a time taken for the P to move from O point to P point. So multiply by omega, you will get a theta. How is this possible? Now you know that theta is nothing but a radian, omega is nothing but a radian per second, T is nothing but a seconds. So second gets cancelled, you get only a radian. So theta is equal to omega into T. So theta is equal to omega into T. Okay. Now let us start with, now you know that let us consider this triangle. Now which triangle you will consider? You have to consider, guys, you have to consider some triangle, no? Very sorry. Hello. Which triangle you will consider now? Let us say that you consider this triangle. Okay, you consider this triangle. If you are considering this triangle a right angle triangle, okay, so this OP is what? OP is nothing but a hypotenuse, right? Now tell me what is sine theta? What will be the sine theta? Opposite side upon hypotenuse. Now if this is the theta, what is the opposite side? This is nothing but the opposite side, right? Let us say this point is M. Okay, so let me read this. Let us say this point is M, and I am taking this as a triangle. Okay, so sine theta is equal to what? Sine theta is equal to opposite side. What is opposite side? PM. Okay, PM upon OP. Okay, what is PM? What is PM? Anybody? What is this distance? X. This PM is nothing but the X, right? And what is this OP? OP is nothing but this is nothing but the X, capital X, maximum displacement. So capital X. So from this I am getting X is equal to, small x is equal to capital X sine theta. So small x is equal to capital X sine omega t. Okay. So this x is equal to what? X into sine omega t. So this displacement is equal to maximum displacement multiplied by sine of theta. Now message me, have you understand this concept? How this x is equal to capital of X sine omega t? Please message me fast. Have you understand this or not? Okay. So now go to the derivation, same. So as I said that this derivation may ask for the 5 marks in your examination. So let x is equal to displacement of a point from the mean position after time d, and capital X is equal to maximum displacement of a point from the mean position. This is also called as a, that is the amplitude. Okay. Now we know that x is equal to x sine theta. If I consider this triangle, this is x, this is capital X, this is O, this is N, and this is P, and this is theta. Okay, so x is equal to s sine omega t. Now, guys, understand that if small x is a displacement, x dot is the velocity, and x double dot is the acceleration. हे तुमच्या डोक्यामध्ये फिट ठेवा. Okay, x is a velocity, x dot and x double dot. Is it clear? Okay, so now tell me velocity of a point after time t means what? You have to take derivation of this. So velocity is nothing but x dot. मग ह्या इक्वेशन नंबर 1 चं जर तुम्ही डेरिव्हेटिव्ह घेतलात विथ रिस्पेक्ट टू टाइम dt, तुम्हाला मिळणार x डॉट. सो व्हॉट इज x डॉट? ओमेगा into x cos omega t. Okay. Now take a double derivative, you will get an acceleration. So acceleration of a point after time t is nothing but x double dot is equal to minus omega square x into sin omega t. But what is x into sin omega t? Small x. So acceleration x dot is equal to minus omega square into x. Okay. So finally I am getting x double dot is equal to minus omega square into x. So this, from this equation I will get a fundamental equation. Okay. Now now what does this equation? आता हे इक्वेशनचा अर्थ काय ते महत्त्वाचं आहे. Which equation? x double dot is nothing but acceleration minus omega square into x minus omega square into x means what? Means what? तुम्हाला acceleration, आता बेसिकली एक गोष्ट बाळांनो लक्षात ठेवा, एक गोष्ट लक्षात ठेवा, x is equal to displacement, x is equal to displacement. So x dot is always equal to omega into x. Okay, and x double dot is always equal to minus omega square into x. Okay, means what? If you multiply the displacement with omega, you are getting x dot. If you multiply this x with omega square and sign minus, you will get the acceleration, right? So this is what we have studied. Okay, so what does this say? That it has a अर्थ काय? X double dot is equal to minus omega square into x. It says that acceleration is directly proportional to the displacement from the mean position. Okay, means what? Let us say this omega square is constant. Omega square is constant. So this x double dot is directly proportional to x. Means what? Acceleration is directly proportional to the displacement from the mean position. Okay, and this minus sign indicates that acceleration is always directed towards the mean position, right? Minus sign indicates acceleration is always directed towards the mean position. If there was no minus sign, for example, in case of the velocity, it's omega into x. Means what? The velocity is always directed away from the mean position. Let us say this is हे वाक्य तुम्ही already तुम्ही शिकलाय. Let us say O is the mean position. So x dot velocity is always directed away from the mean position. That is why it is positive. And let us say O is the mean position and acceleration is always directed towards the mean position. हे सगळ्यांना माहिती आहे की ते मला सांगा. It is clear? So that is why x dot is away from the mean position and x double dot is towards the mean position. That is why there is a minus sign here. Okay, and in case of the velocity, there is no minus sign. Okay, and velocity's equation काय होतं? बघा, velocity's equation काय होतं? X dot is equal to minus omega into h cos omega t. Right? Means what? There is no minus sign. Means what? Velocity is away from the mean position. Okay. So now let me come to the definition. So a motion, a proper definition as per the equation. A motion whose acceleration is proportional to the displacement from the mean position and is directed towards the mean position is known as a simple harmonic motion. Means what? X dot is equal to minus omega square into x. A motion whose acceleration is proportional to the displacement from the mean position. Right? Means what? The distance from the mean position is nothing but the x, and x double dot is directly proportional to this x and is directed toward the mean position. That is why this minus sign. And since it is an acceleration, so omega square. Is it okay? Now, this equation x double dot is equal to minus omega square into x. If I take towards the left hand side, equation becomes x double dot plus omega square is equal to x. And this equation is called as a fundamental equation of simple harmonic motion. And this equation will use throughout the subject. So the equation whose this x double dot plus omega square, x double dot plus omega square into x is equal to 0 is called as a fundamental equation of simple harmonic motion. So you have to remember this fundamental equation always. Now guys, tell me, is it clear to you? Message me, is it clear to you or not? So I am stopping here today's lecture. Okay. Everybody, it is clear? Message me yes or no.